This video will address how to solve equations graphically. We'll talk about the intersection method and the zero method. Remember that a solution to an equation is a value or values that make the equation true. We most often solve equations algebraically, but in this video we'll use two graphing techniques to solve linear equations. The first method is called the intersection method. If a linear equation is in the form of f of x is equal to g of x, first we'll graph y1 equals f of x, then we'll graph y2 equals g of x. So essentially we'll graph the right side and the left side of the equation separately, and then we'll find the x-coordinate of the point of intersection. That x-coordinate of the point of intersection will be the solution. So here's the idea. Can you tell on this graph for which x value they are equal? So here we have a graph of f of x, here we have a graph of g of x. Here's the point of intersection, and the x-coordinate of this point represents the solution. So x equals 1 would be our solution. So if we want to solve these two equations using the intersection method, the left side we'll call f of x, and the right side we'll call g of x. We'll type this into y1, we'll type this into y2, and determine the point of intersection. So let's get our graphing calculators, press y equals, enter in the left side. Remember your slope needs to be in a set of parentheses. The right side will be y2, and we'll press graph. Here is our point of intersection. The x-coordinate of this will be our solution to this linear equation. So if we press second trace, which brings up the calculation menu, option 5, then enter 3 times, the x value is equal to 6 at that point of intersection. Therefore, our solution is x equals 6. For this problem, let's go ahead and perform substitution to check our answer. So 2/3 times 6, this would simplify nicely. We'd have 4 minus 5 equal to negative 12 plus 11, which does check because negative 1 is equal to negative 1. So that's how you solve a linear equation using the intersection method. Now it might be a big time saver in a problem like number 2, as long as you're cautious when you enter in f of x and g of x into the graphing calculator. So again, the left side would be f of x, or what we can call y1, and the right side what we call y2 or g of x. Let's go back to our graphing calculators and solve this equation. We'll clear out our previous functions. Now when we type this in, we do have to be careful. We're going to include the numerator in a set of parentheses. So we have the left side in y1. Now we'll type the right side into y2, then graph. So the x-coordinate of this point of intersection represents our solution. If we press second trace, option 5, enter 3 times, this x value represents our solution, x equals 3. So as you can see in this problem, it is a big time saver because in order to solve this linear equation, it would take many steps algebraically, but graphically it's pretty straightforward. One of the drawbacks on this method is if the point of intersection does not occur in that standard window, you may spend quite a bit of time trying to locate that point of intersection. But most of the problems from our text, the intersection point will occur in that standard window. Let's go ahead and take a look at our second method, called the zero method for solving equations. For this method, what we do is we set the equation equal to 0. The form will be f of x equals 0 or 0 equals f of x. Then we'll graph y equals f of x. Using this method, we look for the x-intercept, also called the 0. The x-intercept is the solution to the equation. So we do have to perform some algebra to set the equation equal to 0, but then as soon as we do that, we do resort back to graphing. So here's the idea. Look at the graph of y equals f of x. Can you find the x-intercept, or where y equals f of x equals 0? Well, the line crosses the x-axis at x equals 2, therefore the solution would be x equals 2 if this was our graph. So on the intersection method, we look for a point of intersection. On the zero method, we look for the x-intercept. Let's take a look at a couple examples of this method. The first step is we do have to set it equal to 0, so we'll add 36 on both sides. So the right side is our f of x, or our y1. So we'll go ahead and graph this on our graphing calculator and look for the x-intercept. So y1 equals 3x plus 15. Here we can pretty easily see the x-intercept is -5, but the calculator will find that for us if we press second trace and then option 2 for 0. Now when we choose this option, it's going to ask us for the left bound and the right bound. The left bound tells us that we must place the cursor to the left of the x-intercept. And if we're not sure where the cursor is, it tells us that it's right here at -2.3. To the left of this x-intercept in this case would be below. So we move that blinking cursor so that it's below. Anywhere below is fine. Hit enter. Now it's going to ask for the right bound. We need to be to the right side of this point of intersection. We need to be to the right side of this x-intercept. So in this case it would be above. Hit enter and then enter one more time. Now we can see that the 0 is equal to -5, which represents our solution. When we're choosing the left bound and right bound, we're essentially telling the calculator where to look for the 0 or the x-intercept. So in this case, x equals -5. Let's go ahead and try it on number 4. So to set it equal to 0, we'll subtract 3x on both sides. At the same time, we'll also add 8 on both sides. So the result would be 2x plus 2 is equal to 0. So we'll go back to our graphing calculator and graph y1 equals 2x plus 2. Of course, now that we have it in this form, you could probably solve this equation mentally. But let's go ahead and take a look at the graph anyway. 2x plus 2, graph. See the solution there. Let's go ahead and find it using the technology. Press second trace. Option 2. Left bound means to the left side of the x-intercept. So somewhere over here would be okay. Hit enter. Right side of the x-intercept, anywhere up here would be okay. Press enter and then enter one more time. We have a 0 of -1, which represents our solution. So that wraps up how to solve linear equations graphically. Of the two methods, I prefer the intersection method because you don't have to do any algebraic manipulation to the equation. And you can see using the 0 method, you do have to perform some algebra first, which may or may not be easier than just solving it algebraically to begin with. I hope you found that helpful.